to another video of the Ravenclaw Den. This episode, which is the 6th episode, is about carbon dating. It's science, it's physical science, if you want to know what it is. And as before, I will share my screen with you, and I'll teach you and myself about carbon dating and other stuff that might be important. This is a newsella, so I'm going to have to do a bunch of editing, so my answers aren't shown. But I just want you to know that. Hey guys, so we're going to work on carbon dating, which is this. So science. We either have 1, 3, 2, or 4, as you can see on the screen. So I'm in the first class of the first day. Lucky me. So now we're gonna go to Newsella. Let's just okay. Okay. So I'm going to stop the screen share so I can log in. Hang on. I think it's automatic. Okay, let me see here. So yeah, this is okay. So this is Newsella. I don't know why I wasn't joined in the class, but that's weird. Okay, so your assignments. Okay, I'm gonna find it and then I'll be back right here. And you'll see it. Okay, so we can pick one out of the two. We can do determining Earth's age or Earth's history and rocks. There's not a newsella that says carbon dating. So I think I'm more interested in determining the Earth's age, and we're going to have to take notes and all that jazz. So I came up with a new Google Docs to take a note. This is determining Earth's age. Okay, I can't spell fast. Okay, so we're gonna do this together. I'm gonna have it read it out loud because this print is way too small for me. So I'm gonna click this, and then once we start, I'm going to not talk. So now I am going to start the read aloud. Let's see. Okay.
How did scientists calculate the age of the Earth? By National Geographic Society, adapted by Newsella staff. Published January 22, 2020. The Earth has high mountains, deep oceans, and sprawling glaciers. But how old is the Earth? Scientists have determined that our planet is about 4.5 billion years old. How did scientists determine that age? They used geology, math, and chemistry. First, they learned about the rocks and elements that make up our planet. Then they used that knowledge to figure out a way to tell the age of the rocks. Scientific method used, but it yielded poor estimate. In the 1800s, scientists tried to determine the age of the Earth. One of them was a famous Irish scientist named Lord Kelvin. He studied physics and math. Lord Kelvin thought that if Earth began as a mass of melted rock, it had to cool.
Okay, I'm sorry, this is like a joke that my friend and I had, but we were wondering if Lord Kelvin created Calvin Klein, which I think is the cologne brand of Calvin Klein. I don't know. Let's just continue.
He tried to figure out how long it would have taken to cool. In 1862, he said that the Earth was between 20 million years old and 400 million years old. His estimate was wrong. But the way he tried to solve it was right. He drew conclusions based on what he could see or observe. He also drew conclusions based on what he could figure out using math. and on what was known about physics at the time. Although his estimate was wrong, Kelvin used an accurate scientific method, getting closer using relative dating. Scientists also tried to compare layers of rock to figure out the age of the Earth. This method is called relative dating. Scientists try to determine how old each layer is by comparing it to another layer. This method can show which layers are older or younger, or which events happened first. Relative dating could not give scientists the exact age of those rock layers. However, it did tell them that the Earth was most likely billions of years old. Scientists turned to radioactive elements. Advances in science continued. In the early 1900s, scientists discovered radioactive elements. These elements decay, or break down, into other elements. Scientists figured out how each element breaks down, what it turns into, and exactly how long that takes to break down. The amount of time it takes for half of the original element to break down is called its half-life. The decay is like a clock, counting down how much time has passed. Scientists use a certain process to tell the age of a rock or mineral. First, they measure how much of the original element is left. Then they measure how much of the new element has formed. They use the half-life to tell how much time has passed. This method is called radiometric dating. Studying moon rocks produces breakthrough. One problem with radiometric dating is the rock cycle. During the rock cycle, rocks change forms. Old rocks are destroyed as they slide back into the earth. New rocks form when lava cools and solidifies. The rocks are constantly changing. The first rocks that formed on the earth are no longer here. This makes finding an age for the earth difficult. The oldest rocks that have been found are about 3.8 billion years old. However, some tiny minerals have been dated at 4.2 billion years. To get around the difficulty presented by the rock cycle, scientists have looked elsewhere in the solar system for even older rock samples. They have examined rocks from the moon and from meteorites, neither of which have been changed by the rock cycle. Radiometric dating has also been used on those rocks. Scientists have used all of this data to estimate the age of Earth at 4.5 billion years. How did scientists calculate the age of the Earth?
Okay, so it just restarted. So now I'm going to end this clip because I don't have a high security drive. So, a high gigabyte speed. Anyways, so I'm going to end this and then we're going to start back to the notes. Once you click the quiz, you can look back in the paper and you can see, you can see in the like not the paper, the article to take notes. So we're gonna do that, and there's like normally 4 questions. So I'm gonna go to you on that. Okay, so now we're gonna see how many questions the quiz has, so I can make a timetable and all that jazz. Okay, so there's 4 questions. So we're going to insert table 4x2 because we're going to use the question. Which sentence from the article supports the main idea of the article? So, I think you can copy paste this. Okay, and then we're going to do that on the bottom. The Earth has high mountains. Okay, so we're going to look at the answers. And you can change your answers. It's not going to automatically, like if you hit the wrong button. The Earth has high mountains and deep, Lord. What sentence from the article mainly supports the idea of the article? So the article is literally titled, How Did Scientists Calculate the Age of? So we should look at the notes. So the title of the article is called, hang on. Okay, if you heard another woman, that is my grandmother. So on 14, and then I Meriwether. No, stop. How did scientists calculate the age? So we're going to take that and we're going to. Okay, I think the answer is B. If I'm wrong, then E. Read the paragraph from the article. In the 1800s, scientists tried to determine the age of the Earth. One of them was a famous Irish scientist named Lord Kelvin. He studied physics and math. Lord Kelvin thought that if Earth began as a mass of melted rock, it had to cool. He tried to figure out how long it would take to cool. In 1862, he said that the Earth was between 20 to 400 million years. How does this support the main idea of the article? And when we go back, we clicked B. So the melted rock, he thought it was going to cool. By showing the rocks from outside of the Earth can be used as the age of the Earth. By showing the rock, I'm probably gonna get one or two of these wrong. So, by showing how scientists, so basically we're trying to find out what is the age of the Earth. I'm probably gonna get all these wrong, but by showing the rock cycle can make it how hard it is to discover. By showing how one scientist figured out the age of the Earth that we use today. I think that's saying we used this kind of method, but in the same time it wasn't right because he found rocks that were like probably burnt for like 400 million years, and in reality the Earth has reached about 4.3 billion years. And I'm gonna have to research that up. Okay, let me search this. 4.5. Wait. Okay, 4.543 billion years. Wow. That's a weird number. Earth, planet, wow. We already know that. Anyways, read the article introduction, paragraph 1 to 2, and studying moon rocks. Okay, paragraphs 1 to 2. So I think the introduction explains how scientists came up with it, and the introduction explains the first estimated one, and then the final describes the newest one. The introduce highlights what problems with the later. Okay, I think this is D. Why you think, okay, scientists turned to radioactive, elements. Okay, advances in science continued in the early 1900s to, help the reader understand how. No, I don't. Okay. Understand first estimate. Okay. To help the reader understand. Okay. Okay, so the system worked out pretty well, as you heard in the video. I mean, in the read aloud. So I think, how by using, I think I'm gonna fail this. Okay. See, I told you. Like, okay. So you scientists. Oh, see, that was my instinct. The see, see that I told you. I mean, my brain is in the right place, but I can't like think about it. Like, yeah, I'm not embarrassed. I'm kind of. I mean, I don't mind, but like those are some the answers that were given, like the multiple choice answers were almost the exact same thing, but it wasn't meant to be. And so we're going to go to the. So I'm gonna go back here. Okay, how did scientists reading levels? I went, wait. Tough stuff, human, oh god. Oh my god. Okay, so I'm gonna figure out what this means. Wait, answer the 4 quiz questions. So I'm just going to put this, take quiz. Okay, so we're going to review, and we're going to copy and paste my answers. That I'm not gonna lie, because you can see it on the camera. I'm not gonna be lying. So I'm not like a Slytherin. I'm not like, oh yeah, woohoo. Okay. So I might be wrong, but at the same time, I'm still learning. You always learn something new, even if you don't like it. I'm talking to the Slytherins, because the Slytherins would have like made a new thing. I mean, not all Slytherins are the same, but which article? So I chose. Wait, what did I choose? Okay, so we're gonna exit out, and we got 790L. I think, wait, 790L. The central idea of this article is how scientists. I mean, I'm not good at spelling, especially when I'm typing like this. But yeah. Like Lord Kelvin used the right method, but he still got the wrong answer. Now I'm gonna turn this in, and we're going to work on a new assignment. As you know, I do CA, which is copying everything. So this is what CA does. So Control A, that just does that. Control C, and then I'm going to turn this in off camera, and I'll be in person in just a few minutes. Bye. Hey guys, and thank you for watching that video. And if you didn't, I still thank you for clicking on this video, and maybe like, maybe subscribe, maybe even share or comment. So please smash the like, smash the like button. I'm gonna have to try and remember these all. Okay. So smash the like button and the subscribe button, and share it with all your friends, family, close people that are interested in this stuff. And comment on how I can do better. Let's say if you dislike, I want you to be encouraged to comment on how I can make my videos better. I'm sorry if you can hear other people talking. That's my family. They like to be loud.